Hi everyone, welcome to our first lesson on polynomials. Today's going to be super easy. All we're going to talk about is terminology. I'll try to get done as quickly as I can. But it is important to all be on the same page when we're talking about polynomials. And one of the ways we can do that is to all use the same vocabulary. So please make sure you're paying attention to this stuff. We will be using this vocabulary all unit. It will be important to know. Okay, so we should by now know what a variable is. In the case of polynomials, a variable is a letter that represents an unknown real number. So that could be something like m. We should also remember that it can contain exponents. We'll see that lots, obviously. So it could be something like m squared or something like n to the fifth. All of those things will be familiar to you by the end of this unit. So what is a term? A term can contain a number all by itself, or it can contain a variable all by itself, or it can contain the product of a number and a variable. And of course, we can see exponents on the variables as we just talked about. So examples of that would be things like 3. That's an example of a term. Or negative 4m, that's an example of a term. P squared would be another example. All of these are examples of terms. Can the exponents be negative on those terms? Like something like m to the negative 3. We saw that last unit, but in this case, no, we will not use any negative exponents with polynomials. They will all be positive. There's some more examples of terms. Look at things like that. Don't be confused by that because that's really just 1/5 b. And so that 1/5 acts as the number out front. But there's nothing surprising about any of those. Those are all examples of terms. The coefficient is the numerical factor of a term. So if I had something like 3m squared, in this case, this would be called the coefficient. A constant occurs when a term is a number only. So if we had a term like negative 7, or if we had something like 43 with no variables, both of those things would be called constants, but they are also both terms, and we'll use those as we go through this unit in polynomials. So all of these things, coefficients and constants and variables and exponents, they're all used to create polynomials. These polynomials contain or come in multiple different flavors. We'll see monomials, which contain one term. And so we'll see examples of that, like 3m squared or negative 7 p r cubed, or a monomial could also just be a constant, like 11. Or it could be a variable all by itself, like x or xy cubed. All of those things would be considered monomials. They are all single terms. Binomials contain two terms, and they will be things like 3m squared plus 4. That would be an example of a binomial, or 14mn minus 3 n squared. Or 2x cubed minus 3x squared. All of those will be binomials, all containing two terms. Trinomials contain three terms. So we could have something like 3p squared minus 2p plus 11. That would be a trinomial because it contains three terms. And finally, polynomials. Polynomials are sort of like a catch-all term. They contain any number of terms. So it can contain one term, or two or three. So really, everything is a polynomial. A monomial is a polynomial. A trinomial is a polynomial. Something with 17 terms is also considered a polynomial. So a polynomial could be something like 7, because that is a monomial, or it could be something like negative 32xy. That is a monomial, but it also makes it a polynomial. Or it could be something like 3m cubed plus 11m squared minus 2m plus 17. That's a 4-term polynomial. All right, so another little bit of terminology. The degree of a term is the sum, so the addition, of all the exponents on all the variables of a single term. So if we had something like 3m cubed n squared, the degree would be the sum of the 3 coming from here and the 2 coming from here. So the degree is 5. That is the degree of that term. Degrees also relate to polynomials, but to understand what the degree of a polynomial is, we have to understand what the leading term of a polynomial is. The leading term of a polynomial is the term in the polynomial that has the highest degree. So if we had something like 3m cubed n plus 2mn minus 17n squared, and we looked at these, there are implied 1s on all of these. So the degree of this guy would be 4, the degree of this guy would be 2, and the degree of this guy would be 2. That makes this 3m cubed n the leading term of the polynomial, and the leading term also determines the degree of the polynomial. So the leading term gives the degree of the polynomial as well. So for this trinomial that I've just given you, the degree of the polynomial would be 4. Right, so like terms must contain two things. They must contain the same variable, and the variable must have the same exponents on them. And if two terms share those two traits in common, then they can be considered like terms. So let's look at a couple of examples here. I have 3m squared and negative 4m squared. They both have the same variable raised to the same exponents, so those are like terms. Let's take a look at this next guy. We have xy squared, and in this case we have y squared x. They both have the same variable. Each variable is raised to the same exponent. You can see that the y has the squared and the x has an exponent of 1. So again, these would be like terms as well. Just as a little aside, this guy here is written incorrectly. We tend to write things in numerical order of the variables, so that should be correctly written as 5xy squared, and that would have made it easier to see that these were like terms. And then this last example I'll give you, I have m cubed n squared and m squared n cubed. So they do have the same variables, but in this case the exponents are different, so these are not like terms. Now, just to wrap up this video, let's take a look at a couple of things here. Which of these can be considered polynomials? We saw in our last unit that this is the same thing as m to the negative 1. Polynomials cannot contain a negative exponent, so this is not a polynomial. We also saw in our last unit that r to the 0 is equal to 1, because anything raised to the 0 power is 1, so it doesn't matter what the value of r is. So that would be 1 plus r squared. That is a polynomial. As a matter of fact, it's a binomial. Negative 7, that qualifies as a monomial, so that guy as well is a polynomial. This is a 3-term trinomial, so that is a polynomial. And this last guy, it's a bit different. It is a square root of a binomial, but that square root sign is the same thing as a fractional exponent. You'll look at that later on in your math career. And in our case, that is not a polynomial, having that fractional exponent disqualifies that from being a polynomial. So that's all my terminology today. There are some important ones that we will use constantly. The most important ones out of this lesson, the most important ones out of this lesson would be like terms. That will be crucially important as we go along. And then the terminology of monomials, binomials, and trinomials. We'll be talking about that throughout this unit. Thanks a lot. I hope you have a great day. Take some notes, and that's it.